Hello, today I am going to solve this question cheapest flight within K stops, right? So here we are given with an n cities connected by some number of flights, and flight is represented by this uh, array. You can see here, you can see the starting and ending station and the price of the ticket there. And there are three integer also given to us, which is source, destination, and K. We have to return the cheapest from the source to destination with or at most K stops, right? And if there is no search route, we have to return -1, right? So in this question what we have to do is we have to calculate the cheapest flight with K stop in between, right? So in the example number one, as you can see that for n equal to 4, the flights are given here and source to destination is 3, and the maximum number of stops that we can choose is 1, right? So here from starting from 0, if we look closely, so the um, minimum flight we like, if we have a foundation of using any much of stops, so the most number of stops could be used, and the minimum number of weight should be 100 plus 100 plus 200, this path, right? And the resultant will be 400, and the number of stops will be 2, 1 and 2, right? But we are here, we have a restriction of only one stop to use in between, right? So here we can see that to use only one stop, we can go via 0 to 1 and 1 to 3, and our cost will be 700. So here as I can see that we have to iterate over all the iteration of like we have to start a bfs from this position and go to the every position which is being possible from there, right? And like it's kind of doing a dfs or bfs from iteration from each and every step and calculating whether I have exhausted this much of a stop in the between, right? So if I have exhausted one stop in between and our cost is whatever it is, if it is not infinity, I will return that cost into our answer, right? So similarly, in the following example, you can also verify, right? So in this question, I can see that we can use a graph algorithm, which is Bellman-Ford. So it's a simple DFS approach where we have to count the current reachability of point any node from the source node where we have started, right? And we can iterate over the number of stops there, and at the number of stops which is been allowed there, whatever there is the answer, right? If it is less than infinity, we will return that answer. If it is infinity, we will return -1, as it is not possible to go there, right? So I hope you understand my approach, and if you need any complete explanation of how the Bellman Ford, Dijkstra, minimum spanning tree, all this stuff work in graph, you can comment down in below in the video. I can make a separate video of complete graph, how it works, like how the different famous algorithms of graph works, right? So let's dive into the coding part, and let's try to submit this in Java and C++. So I have added all the comments which has been useful for you. So first we find out the key stop minimum ticketed price from source to any node which is there out there, right? And we will get our destination ticket price at that conditions, and if it is infinity, and like if it is infinity, I will return -1, and other than that I will return the value which is present there, right? And initially what we do is we have two nodes from, so like previous and current. Like previous, initially the previous will be infinity, other than source we can't reach any node, and we assume that the reaching to other nodes from source is infinity, right? The ticket price is infinity, and then we update our current price with the help of the weights which are given there, right? So this is how I solve this question in Java. So let's try to submit this question. So this is the solution for today's daily lead code challenge in Java. So let's try to submit this question in C++. So all the test cases are passing in C++. Let's try to submit this. Okay, so this is the solution for today's daily lead code challenge. If you have any doubt in this question and Bellman Ford and other any graph algorithms, you can comment down below. I will make a separate video for that. Thank you for watching.